There we go. This Zoom session is being brought to you by the Fractal Bullseye Water. All right. For today, we'll be going through sections 4.3 and 4.4. 4.3 will be covering logarithmic functions, and 4.4, the laws of logarithms. We start with this log base a of x, written this way. A is a subscript. It's the inverse of the function a to the power x. This is a logarithm base a. This is the exponential base a. Inverse means that they undo each other. A to the power log base a of x is x. X is the power of log base a of a to the x. So they undo each other. Or in other words, y equals log base a of x if and only if a to the y equals x. So it's a kind of transposition. If here's a graph of y equals a to the x for a bigger than 1. It goes to 0 by 1, it goes to 1 by a. If a is bigger than 1, then it starts very small and ends very big. The inverse, the graph of the inverse, you find by flipping the graph of the function through the diagonal. And you get this graph here. It goes to 1 by 0 and a by 1. So log base a of 1 is 0. Log base a of a is 1. These are counterparts to these equations. It starts out going to negative infinity fairly quickly, and it goes to positive infinity very, very, very slowly. Okay, now there's a special logarithm, ln, called the natural logarithm. It's log base e of x. E is a special constant, about 2.718. You can find it from working from continuous compound interest. Also, E shows up in lots of places in math and biology and physics and engineering and so on. Anyhow, so it's log base e, so ln of e to the x is e to the ln of x is x. So e to the x grows like this, then ln of x, its graph is like this. Why the name natural logarithm? Well, if you take this graph, y equals 1 over x, like that, and draw a vertical line at x equals 1, another vertical line at x equals k, then this area, this region between these three lines and this curve, the area is ln of k. So it shows up in the math, it follows straight out of some simple math. You'll see this when you get to calculus, and so therefore the name natural logarithm. Now, for example, log base x of 81 is 2 for what value of x? Well, all right, you transpose. A logarithm base x transposes to an exponential base x. So 81 is x to the second. So take square roots, and x equals 9. Log base 5 of 125 equals x, and what's that? Well, log base 5 of 125, you can rewrite 125 as 5 to the third power. And since logarithm base 5 and exponential base 5 are inverses, what's left is the exponent 3. Here's log base x of 5 to the third equals 3 for what value of x? Well, we transpose the x and get 5 to the third equals x to the third. Cube roots gets you that x equals 5. Log base 100 equals 3 halves for what value of x? Well, here we transpose a logarithm base 100 on one side becomes an exponential base 100 on the other side. So x equals 100 to the 3 halves. 100 is 10 to the second. So 10 to the second to the 3 halves, you multiply the exponents. That's one of the laws of exponents. So x equals 10 to the 2 times 3 halves, or 10 to the third. So x is 1,000. Log base x of root 3 over 3 is a half. What's x? You transpose a logarithm base x, it turns into an exponential base x. So root 3 over 3 equals x to the 1/2. Square both sides, get x equals root 3 over 3 squared, which after a little bit of arithmetic gets you x equals 1/3. Okay, log of a million is what? Now, when you don't have a subscript, it means common log or log base 10. Common log because that's sort of well, we use log base 10, and so it's useful when humans are calculating math. Time was that a really good math text would have at the back a table of natural logarithms and common logarithms and maybe sines and cosines. But that grew obsolete when it turned out you could buy a calculator with all those functions available at a push of a button for what, $20, $100, whatever. So technology made certain textbooks obsolete. Anyhow, Common log of a million is what? Well, it's log base 10 of a million is 10 to the 6th. Logarithm and exponential cancel, and you get 6. Is common log of 1/10. Well, what's that? Well, log of 10, base 10 of 1/10 is 10 to the negative 1. After cancellation, you get negative 1. Log of a half is 1/32. What's that? Well, it's log base a half of 1/32 is the 5th power of a half, because 32 is the 5th power of 2. And again, after cancellation, you get 5. Log base 9 of 3 is what? Well, 3 is the square root of 9, which is 9 to the half. So this is log base 9 of 9 to the half. Cancellation gets you 1/2. Natural log of the cube root of e squared. What's that? Well, a cube root of a square is a 2/3 power. So this is natural log base e of e to the 2/3. Cancellation gets you 2/3. ln of x is 4.24 for what value of x? Well, if ln is 4.24, then transposing ln, you get log base, exponential base e. So x is e to the 4.24, which the calculator will tell you is about 69.4079. Natural log is negative 3.71. What's x? Well, you transpose the log, get an exponential base e. X is e to the negative 3.71, approximately 0.0245. All right.